Hi guys, welcome all of you. This is Reena B. George from RVGMATHS Talents. Let us start next part of the class, Chapter 2, Polynomials, Part 3. Okay. In this class, we are discussing geometric meaning of the zeros of cubic polynomials. Okay. Let us start. If you are struggling with maths, you can get free notes from my website. Its link is given in the description. Let us see cubic polynomials. Consider the cubic polynomial x cube minus 4x. Okay. Let us draw the graph of this polynomial. For that, we are substituting some values for x and we are getting the corresponding values of this polynomial. So if you substitute x equal to minus 2, we are getting 0 for y equal to x cube minus 4x. Okay. If you substitute the value x equal to negative 1, we will get y equal to 3. If you substitute x equal to 0 in y equal to x cube minus 4x, we are getting the value 0 for it. Okay. If you are substituting 1 for x in y equal to x cube minus 4x, then we are getting y equal to minus 3. If you are substituting x equal to 2, we are getting y equal to 0. X equal to minus 2 gives y equal to 0. X equal to 0 gives y equal to 0. X equal to 2 gives y equal to 0. That means the zeros of this polynomial are minus 2, 0 and 2. And if we plot these points, we will get the graph like this. Then we can see a graph like this and it cuts the x-axis at this point and this point and this point. That means these 3 points are the intersecting points of x-axis and the graph. Okay. Which are these points? See, minus 2, 0, 0, 0 and 2, 0 are the intersecting points here. See this? Minus 2, 0, 0, 0 and 2, 0 are the intersecting points. Then if you observe the graph, you can see the curve meets the x-axis only at these 3 points that are minus 2, 0, 0, 0 and 2, 0. Then you can see the x coordinates are the only zeros of this polynomial. In the case of quadratic polynomials, we have seen the zeros of the polynomial are the x coordinates of the intersecting points of the graph with the x-axis. Is it? The same thing we can see in the case of cubic polynomial also. The graph intersects the x-axis at some points and the x coordinates of that points are the zeros of the polynomial. The links are given in the description for helping books in CBSE studies. So you go through that links and you can buy that books. It will be supporting for the channel, but it will not make any more course for you. Let us go to the class. Let us see another cubic polynomial. Y equal to x cube and its graph is given here. See here, the graph intersects the x-axis at one point, that is 0, 0. Okay. That means the x coordinate of this point is 0. And 0 is the only zeros of this polynomial. Y equal to x cube. Here if you put x equal to 0, then y equal to 0 cube, that is 0. That means x equal to 0 is the only 0 of this polynomial. We cannot find any other 0. 0 is the only 0 of this polynomial y equal to x cube. And 0 is the x coordinates of the only point where the graph intersects the x-axis. Is it? Have you understood this? See, the 0, 0 is the only point where the graph intersects the x-axis, and the 0 is the only 0 of the polynomial x cube. Consider another polynomial x cube minus x square. Then let us draw the graph of this, and we are getting the graph like this. Y equal to x cube minus x square. See, observe this. At this point the graph cuts the x-axis. At this point the graph cuts the x-axis. So which are the points? 0, 0 and 1, 0. That means the x coordinates of these points are 0 and 1. See here, if you put the value x equal to 0, you are getting y equal to x cube minus x square, that is equal to 0 cube minus 0 square, that is 0. Okay. If you put x equal to 1, then what are you getting? X equal to 1, 1 cube minus 1 square, that is 1 minus 1, that is equal to 0. That means x equal to 0 and x equal to 1 are the zeros of this polynomial. That are the x coordinate of the intersecting points of the x-axis and the graph. We can conclude, considering the graph of y equal to x cube minus x square, 0 and 1 are the only zeros of this polynomial. These values are the x coordinates of the only points where the graph intersects the x-axis. From these examples, we get any polynomial of the degree 3 can have at most 3 zeros. See, this is the graph of y equal to x cube minus 4x. Here, the graph intersects with the x-axis at 3 points. That means it has 3 zeros. This is the graph of y equal to x cube minus x square. Here the graph intersects with the x-axis at 2 points, and this polynomial has 2 zeros. And the zeros are the x coordinates of the intersecting points. This is the graph of y equal to x cube. Here the graph intersects the x-axis at 1 point, that is 0, 0, and here the x coordinate is 0, and 0 is the only 0 of this polynomial. So, from all these examples, we get any polynomial of the degree 3 can have at most 3 zeros. Some cases, we get only 1 zero. In some cases, we get only 2 zeros. In some cases, we get 3 zeros. That means at most 3 zeros. Okay. Have you understood this? Let's see one example. Look at the graphs given below. Find the number of zeros of p of x in each case. See, some 6 cases are given here. See the first 2 cases. Here, we want to find the number of zeros of this p of x in each case. See, already we have seen that the zeros of a polynomial are the x coordinates of the intersecting points of the graph with the x-axis. Is it? See here, the graph is given here. It intersects with the x-axis at this point. That means only one point. Is it? Then it has only 1 zero. So number of 0 is 1 in this case. What about the number of zeros of this graph? See here, the graph intersects with the x-axis at 2 points. These are the 2 points. That means there are 2 zeros in this case. Is it? And which are the zeros of this polynomial? That are the x coordinates of these two intersecting points. Have you understood? Okay. Here also we are asked to find out the number of zeros. See this, the graph intersects the x-axis at this point, and this point. That means there are 3 points where the graph intersects with the x-axis. That means the number of zeros are 3. So 3 zeros are here. Is it? See here, it is a line. It intersects the x-axis at only 1 point. That means the number of zeros is 1. Only 1 0. Come to the next one. Here in this graph, we can see this graph intersects with the x-axis at only 1 point. That means only 1 0 in this case. Then what about this? Can you say? See, this point is an intersecting point. Is it? The graph intersects with the x-axis at this point, then at this point, then at this point, and at this point. That means this graph intersects with the x-axis at 4 points. Okay. That means 4 zeros. Okay. Then we can say this is not a linear polynomial. It's not a quadratic polynomial. It's not a cubic polynomial. It is a higher order polynomial. Is it? It has 4 zeros. And zeros are the coordinates of these intersecting points. Have you understood? Okay. So, the solution is given here. Number of zeros is 1 in the first case, 2 in the second case, 3 in the third case, 1 in the fourth one. See this? Fourth one, it is 1. Is it? Then in the fifth case, it is 1, and in the sixth case, it is 4. Okay. I think all of you understood this. That means the geometric meaning of the zeros of a polynomial. Okay. I think all of you understood the class well. If you have any doubts, you can go through the classes again, and you will understood it definitely. Okay. Thank you for watching. Let us see in the next class. Okay.